In this video, we would be observing demonstration for downloading of experiments to an ARM9 board from 20sim software using a 4C toolchain. I would be using a couple of experiments related to analog only so that we can see the ADC-DC capability of the ARM9 board. Let's start with some signal generation. I go to the library of the 20sim software, the signals sources folder, and if I scroll down, I can see various analog signals like sine, cosine, triangles, ramp, sweep, and many of them. Okay, maybe I just take a triangle wave. So there I have a triangle signal. Okay, and I take a single monitor. So I just join them two. So there I have a simple triangle signal which can be downloaded to the hardware. I will simulate this. So thereby you can see a signal coming out from ranging from 0 to 1 in amplitude and angular velocity as 1 radians per second. I can change that frequency to revolutions per second. Let's say I start with somewhere like 25 Hertz. Okay, 25 revolutions per second. And amplitude I can, as my ADC-DC analog output capabilities from 0 to 5 volt. So I can use something like 5 volt, but let's say just to demonstrate the capability, I can just mention 3.5. Later we would be able to change this value in the hardware itself. Okay, so thereby you can see the signal and this. I would like to change the integration method to Runge 4 and the step size at least 1 kilohertz. Okay, and maybe okay, so it runs for 10 seconds. Okay. So this is what the triangle signal we should be able to observe. To download the signal, you have to just go to tools, the real-time toolbox, see code generation, select the sum model triangle, say OK, and select the 20sim 4C toolchain and say OK. So it should create a folder, an experiment. As I tried this experiment earlier, so he opens with ready-made config of an ARM9 board. I'm using a TS7300 board. So once you select this, you have to connect the output to an suitable DAC and disconnect and demonstrate again. So it has analog output, digital to analog, TS ADC. Okay, that is the board I would be using. And you can select any of the analog output channel. Say OK, say apply. You have to compile. Okay, thereby you can see that compilation is successful. Now we can download this code. Hi, my name is Vinay and today I will be demonstrating a 20sim software and its interface with ARM9 board. So 20sim software is a dynamic modeling and simulation software package. You can find the information on its homepage, that is www.20sim.com. It is for robotics, mechatronics and various purposes which can solve most of the problem from dynamic modeling areas. It also has capability to extend its control or any algorithmic models into the hardware. It can convert them into C codes and that can be downloaded into boards like this. So today I would be using a TS7300 board. Okay, that is on the bottom one, and on top of it, it has been plugged with an analog to digital converter card. So it has 16 channel inputs, analog inputs, and 4 analog output channels. The inputs are 16-bit resolution and the output DACs are 12-bit resolution. So thereby you can see that that is the DAC output which I have connected to an oscilloscope. So I have an oscilloscope today over here with me along with the function generator. so which I will be making use of it later. I won't be connecting it right now. Okay, so I'm only using one channel of oscilloscope. So the model with I'm starting is a triangle wave selector. So thereby you can see that there is a triangle wave which generates and triangle signal. That's quite obvious. And what I'm doing is I'm asking the software to convert this into an C code and use it a 4C toolchain. So I'm making use of a 4C toolchain with the help of which we can download this. So I have configured this 4C toolchain. This will run for 30 seconds and with a discrete time interval of 1 kilohertz. So I just click on the play or upload and start. So it has started running the code. So we can come to CRO and see the output observed. So thereby you can see that the output is almost 0.2 volt and with the frequency of 25 hertz. Now I can make a change over here, and these are variables. So the amplitude, and this is the omega, that is the frequency, and the previous it is in the angular velocity, which is 157. Let's say I make it to 100 angular velocity. I just say apply and click on upload and start the model. So thereby we can see a change in the output at the CRO side. So the frequency I reduced to 16 hertz and the amplitude goes to almost 3.2 or some voltage. So this is what you can do with this setup. Okay, thank you very much.